Good evening. Sorry for not being able to come to school because I'm not feeling well. So I am recording this as a simple discussion for the next lesson in logic. So it will be about tautology, contradiction, and contingency. So these are the learning goals that you need to do or to learn after this short video. But first, let's start with the concept of converse, inverse, and contrapositive. Let's say you have two propositions P and Q. Then if we have the conditional statement P to Q, then the inverse would be negating statement P and negating statement Q. Now, for converse, you are just going to flip the two statements together for it to get the converse. And for the contrapositive, from the original conditional statement, you will flip the two statements and then you will negate them. So here the example, we have statement A implies statement C. So for the original statement, it will be if there are no lions in the cage, then the capital of Bulacan is Bukawi. Now for the converse, as stated earlier, you will just get or switch the position of A and C. So the converse of A implies C becomes now C implies A. So the converse will be if the capital of Bulacan is Bukawi, then there are no lions in the cage. And now for the inverse, it will be just negating the original statement. So you will negate A and negate C. So the resulting will be the negation of A implies the negation of C. So the statement will become if there are lions in the cage, then the capital of Bulacan is not Bukawi. Now for contrapositive, you will switch the original statement A implies C to become C implies A and then negate them. So it will become the negation of C implies the negation of A. So the statement will become if the capital of Bulacan is not Bukawi, then there are lions in the cage. So if we now have the combination for the different forms of the conditional statement. So what is the contrapositive of the converse of the inverse of A implies C? So how would you go about it? So first get the inverse of A implies C. So the inverse of the A implies C is simply negating the two propositions. So you will have the negation of A implies the negation of C. Now for the converse of the inverse, you will just switch the position of the negation of A and negation of C. So the converse becomes the negation of C implies the negation of A. And the last will be the contrapositive of the converse of the inverse. So from negation of C implies negation of A, you will switch the two. So it will become the negation of A implies the negation of C. But since you are getting the contrapositive after switching them, you will negate them. So you have the negation of A implies the negation of C. Now, applying the double negation law in logic, it's like negative times negative, you will have positive. Negative times negative, you will positive. So the contrapositive of the converse of the inverse of A implies C is just simply the original statement. So we will now be moving to the actual lesson about tautology, contradiction, and contingency. So for a statement or for the compound proposition to be a tautology, the condition wherein a compound proposition is always true for all possible truth values of the proposition that occur in it. Meaning, even if you consider for the different conditions of the compound propositions, it will always be true. The conclusion will always be true. So it will be denoted by the Greek symbol tau. Then you have the concept of contradiction. So it's a condition wherein a compound proposition is always false for all possible truth values of the propositions that occur on it. So for the combination of different compound statements or compound propositions, the outcome would always be false, and it will be denoted by the symbol null set or no set at all. And for the last, for the contingency, is a condition wherein a compound proposition is neither a tautology nor a contradiction for all possible truth values of the propositions that occur in it. So meaning, a statement or a compound proposition will be called contingency if the conclusion will have a mixed outcome of true and false. So let's prove the following using the truth tables. So let's first prove that P implies Q is logically equivalent to negation of Q implies P. So using the truth tables, we will consider all the possible conditions for the statements P and Q. If you have only one proposition, then you will have two conditions, that it will be true or false. Since you have the statements P and Q that is included for the truth values, then you will have four conditions. You have true, 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 false, false, true, and false, false. So we will be proving using the truth values. So our goal here is to find that the conclusion will be a tautology. So how did it become a tautology? So let's first consider the first condition, or for the first compound statement. You have P implies Q. So following the rules or the truth table for the compound proposition conditional statement, if we have true and true, you will have true. True becomes false, therefore false. False, then true, that becomes true. False implies false, then becomes true. So since we are needing for the second part of our proving is the negation of Q implies the negation of P, we need first to find the truth value of the negation of P and the negation of Q. So for the negation, you will just only get the opposite truth value of each condition. So originally, P is true, true, false, false. Therefore, if you negate, it becomes false, false, true, true. And for Q, you have true, false, false. So negation will become false, true, false, false. Since we have successfully made the truth value for the negation of P and the negation of Q, therefore we can now find the truth value for the negation of Q implies the negation of P. Since the conditional statement starts with the negation of Q, so we will not go from left to right, but rather we will read the truth value from right to left, because that is the conditional statement. So you have negation of Q implies the negation of P, so you have F implies F, therefore true. True implies F, therefore false. False implies true, therefore true. So true implies true, therefore true. Now, since we have completed the conditions for the P implies Q and the negation of Q implies the negation of P, how are we going to prove that they are logically equivalent? Now, in logic, if two compound statements are logically equivalent, therefore they are biconditional. So we will prove the truth value for the biconditional that it must always be true for it to be a tautology. So we will be looking here from P implies to Q, and the truth value from negation of Q implies the negation of P. So the biconditional statement will always be true if the two truth values will be equal. So if we have here true and true, you will have true, false, false, true, 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 then you have true and true, that means true. Now, for the second example, you have Q implies P. It must be logically equivalent to the negation of P and implies the negation of Q. So following again, the statements P and Q, you have true, 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 false, false, true, false, false. So we will start with Q implies P. So you have true, true, then true, false to true, then becomes true, true becomes false, then becomes false. So false, false, it becomes true. Then we get the negation of P and the negation of Q, since it's vital for the compound proposition. So this becomes false, false, true, true. Then for the negation of Q, you have false, true, false, true. Then for the compound statement, you will get now the negation of P implies the negation of Q. So we will now read it from left to right. So you have false implies false, then for true. False implies true, therefore true. True implies false, therefore false. True implies true, therefore true. Since you have now the truth values for Q implies P and the negation of P implies Q, we will now get their biconditional truth value. So again, for the biconditional, they must have the same or equal truth value. So you have true, true, therefore true, 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 therefore true, false, false, therefore true. Then you have true, true, therefore true. So for number 2, you have also the tautology. Now, for number 3, we have P implies Q, which is logically equivalent to the negation of P or statement Q. So again, write the truth values for the initial primitive propositions. We have P and Q. So it is vital that we need the negation of P, therefore the truth value for the negation of P provided by this column. Then you have P implies Q. So you will look at the primitive propositions: true, true, therefore true, true, false, 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 true, true, false, false, therefore true. And then you will have the disjunction of negation of P or Q. So this is the disjunction. Therefore, for the truth value, for it to be true, one of the statements must also be true. So you have negation of P or Q, you have false or true, therefore true, false or false, therefore false, true or true, therefore true, true or false, therefore true. Since you have now the truth values for P implies Q and the negation of P or Q, you will have the biconditional statement. So they must be equal. True, true, therefore true, true, false, false, therefore true, 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 therefore true, and then for true and true, therefore true. So number 3 is also an example of a tautology. And for the last example, you will have the negation of P implies Q is logically equivalent to P and negation of Q. So again, start with the initial truth values for the two primitive propositions. Now this time we will be needing the negation of Q. So you have false, true, false, true, because you will be getting the opposite truth value for the statement Q. Then we will be needing, first, before you negate the P implies Q, you need the truth value for P implies Q. So you have true, true, therefore true, true, false, 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 true, true, false, false, true. Then you will get the negation of this one. So from being true, false, true, true, it becomes false, true, false, false. Then for the right side of the logical equivalence, you will get P and the negation of Q. So the conjunction of two compound statements, the conjunction of two primitive propositions will only be true if both of them are true. So you have P and the negation of Q. So you have true, false, therefore false, true, true, therefore true, false, false, therefore false, false, true, therefore false. So we now have the negation of P implies Q, and P and the negation of Q. So we will see if they are logically equivalent if the truth value for their biconditional statements will all be true. So by checking them, so false, false, you have true, 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 therefore true, false, false, therefore true, false, false, therefore true. So the biconditional statement of these two compound propositions will have true for all conditions. Therefore, statement number 4 or logical equivalence number 4 is also a tautology. Now, for the last examples, you need to prove that each compound proposition is either a tautology, a contradiction, or contingency. So let's start first with number. So for number 1, you have P and Q implies R and the negation of P and the negation of Q. So you will be dealing with 3 primitive propositions. Earlier, we have only discussed about 2 propositions. So it will only be good for 4 possible conditions. Since we have 3 conditions or 3 propositions, the conditions will now become 8. So these are all the possible conditions in which 3 propositions will be included. So for P, you have 4 true, 4 false. For Q, same number but with alternating pattern. So you have true, true, false, false, true, true, false, false. And for the last proposition, you will have an alternating result. So true, false, true, false, true, false, true, false. Therefore, the 8 possible conditions for the 3 propositions will be completed. Now, for the first part or the left side of the proving, we have P and Q. So therefore, we will have the conjunction of P and Q. So the conjunction will only be true if both compound or primitive propositions will have the same truth value. So you have true and true, therefore true, 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 therefore true, true and false, false, true and false, false, false and true, false, false and true, false, 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 false and false, therefore false. Now, we need the negation of P for the second part of our proving. So therefore, the fourth true and the fourth false will be negated. So this becomes 4 false and then 4 true. Then we will be having the negation of Q. So if you have the alternating true and false, that will start for true. So for the negation of Q, it becomes false, false, true, true, false, false, true, true. Then for the second part, you still need to get the conjunction of R and the negation of P. So again, for them to be true, R and the negation of P will need to be both true. So you have true, false, therefore false, 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 true or false, false, false and false, false, true and true, therefore true, false and true. So we'll be having R, the negation of, and the negation of P, negation of Q. So we will be using this table and this table. So you have false, 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 true, false, false, true, false, false, true, false, true, false, 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 true and true, therefore true, true, false, false, excuse me. And now to get now the implication, so we will be getting the implication of the first statement, which is P and Q, and then implying statement 2, which is R and negation of P and the negation of Q. So to avoid confusion for long writing of statements, you can use numbers to symbolize with what proposition are you getting to. So if you have statement 1 implies statement 2, so you will apply here P and Q becomes statement 1 rather, and R and negation of P and negation of Q will be statement 2. So if you have the implication, so you have true and true becomes false, therefore false, true becomes false, therefore false, false becomes false, therefore true, false becomes false, therefore true, false becomes false, therefore true, false becomes false, becomes true, false becomes true, therefore true, and then you have the last false becomes false, therefore true. So here you could see that it almost became a tautology, but since you have the first 2 conditions to be false, so it's neither a tautology nor a contradiction because it is not all false. So you have the mixed possibilities of false and true. Therefore, this is an example of a contingency. So for number 2, you have the statement A implies or is biconditional to B or C, implies that you have the biconditional for A or C and the biconditional if and only if negation of B and C. So for the first 10 correct students who will pass their solution today on October 8, 2019, you have the deadline. For Statler, you have only until 9:30 a.m. to pass, and for Tesla, you have only 11:30 a.m. to pass it. So for those 10 students the first 10 students that will get the correct answer For the proving for number 2, will have plus 10 points in their last monthly examination. Again, this is for the monthly examination, and I will only give the full 10 points if we have all the correct solutions. So I need to see a replica of this one. So the solution must be like this, and I will check each every statement. So I will not only consider the last part of the proving, but also every column of your proving. Again, you will be eligible to get the 10 points if all of the truth values for your column are correct. So that will be the end of the discussion for lesson number 3 for logic. So the subject teachers, or for the proctors that will be substituting for me, will give you the activities that you need to do. So again, I'm sorry for being absent at this time, and I will promise to make it up for the remaining days. Thank you.